Okay, so I'm going to work a couple of the problems on this practice test, same one I was using before, just to kind of talk about them. And I worked some of these in my B period, so I figured I'd work them for you guys also. So the first one, find a closed form formula for a to the n, the nth term of the sequence below. So we have two formulas. Remember I told you the two formulas. So our two formulas, a to the n equals a to the 1 plus n minus 1 times d, where a to the n equals a to the 1 r to the n minus 1. So the first one is if it's arithmetic, if you're adding a common difference every time. The second one is if it's geometric. So we need to see. So it doesn't look like it's arithmetic, right? Like I can't add something to root 2 to get 2 because I can't add another number to root 2. I mean, that would be what? Root plus root 2. So if I did root 2 plus root 2, that would give me 2 root 2. Nope, that doesn't work. So I can't, there's nothing I could add. Geometric, can I multiply it by something? So to figure out if it's geometric, we'll divide them. So 2 over root 2 is our first one. Our next one would be root 6 over 2. So these are not equal, right? That's not the same thing. I could rationalize and get 2 root 2 over 2, which is just root 2, so that doesn't work. So these are not, it's not arithmetic, it's not geometric. So I can't use those two formulas. So this is when, and I don't know how Mr. Blackburn showed you guys, but this is when I would go n equals 1, 2, 3, 4, 5, 6. And I would look at that. I could also, because this one's kind of hard, right? I could also make everything into a root. So what if I did that? So n equals 1, 2, 3, 4, 5, 6. So I'll do that. 1, 2, 3, 4. Yeah. Oh, whoops. This is the same thing. There. Okay. So if I make all these into a root, this is root 2. 2 is the same as root 4. 3, this is root 6. 2 root 2 is the same as root 8, root 10. That looks a little bit better, right? So I know that I have a to the n equals, we know it's a root, and then I'm just taking my n and multiplying it by 2, right? 2n, 2 times 2 is 4, 2 times 3 is 6, 8, 10. So this is the square root of 2n. That is a closed form formula or explicit formula, and that gets me all of them. The next one asks for recursive. Recursive means you need to have a first term and an nth term formula. So we're not going to use one of these up here. We're not going to use one of these two because those aren't going to give you a recursive form. Those are explicit. So recursive, first thing I'm always going to put as my a to the 1 is 256. So we know we have to put that one. It has two parts to it. Now a to the n equals, and let's see, what are we doing? So we're taking 256, square root of that is 16, square root of 16 is 4, square root of 4 is 2, square root of 2 is root 2. So we're actually square rooting the previous term. So a to the n minus 1. So that means I'm taking the whatever, so if a to the 3 is going to be the square root of a to the 3 minus 1, which is the square root of a to the 2. So here's a to the 3, and it's the square root of 16. That works. So check it if you want to check it. The next one we have, right, we're trying to find the partial sum, right, the fourth partial sum of this sequence. We have three summation formulas, but we don't need to use a formula. We have the four terms. We're just trying to find the partial sum, so we're just going to add them together. So S of 4 equals 1 plus 1/2 plus 1/3 plus 1/4, right? We're just adding them. We don't need to put it into a formula. We don't need to figure out the nth term. We just need to add them together. So common denominator here would be 12. So that's 12 plus 6 plus 4 plus 3 over 12. So 10, 22, 25. I'm just going to work a couple more with you. You can obviously go to your practice test and see how they're worked because the answers are posted. But number 7, arithmetic sequence. So we know we have a formula. So there's our formula. We know a to the 1 is 11, and a to the 51 is 361. So let's plug in what we know to the formula. So we know 361 equals 11 plus, if I'm doing a to the 51 is 361, then my n is 51. And we're trying to find the d, so we need to solve this equation for d. So 350 equals 50d divided by 50 divided by 50. So d equals 7. That's the common difference. All right, I'm going to skip those. This one, it says, evaluate the following sum if it converges or state that it diverges. Whoa. So because this is not an infinite sum, it's not going to diverge. Also because you can sum it to that many because you're going to have that many things. Also, our rate, or our r, is a fraction less than 1, so it's or greater than -1. So that would work. So we're going to use our sum formula. This is 1, so we can use a to the 1 times 1 minus r to the n over 1 minus r. So a to the 1, let's figure what that is. 24 fifths times -1 fifth to the 1. So you get -24 over 25. There's your a to the 1. R is -1 fifth, and is 19 minus 1 plus 1, which is 20. Yeah, I did not just say that 19 minus 1 plus 1 is 20. 19 minus 1 plus 1 would be 19. So, yeah, good. All right. So we knew, this is how I like to write it. We need to know our R, we need to know our A, we need to know our N, our RAN. So R is -1 fifth. A to the 1 we just found is -24 25ths. And N is 19 minus 1 plus 1, which is just 19. So I'll change colors so we can work it. So this says simplify reasonably. We know we have fractions, we know we have exponents, so we're going to have to figure out how to simplify this. So we have s of 19 equals -24 over 25 times 1 minus -1 fifth to the 19th over 1 minus -1 fifth. So we have -24 over 25 times -1 fifth to the 19th is going to be a minus, right? Because it's going to be like negative when you do that. So 1 minus a negative is going to give you a plus. So that's 1 plus 1 over 5 to the 19th over, this turns into a plus, 1 plus 1 fifth is 6 fifths. All right, we can, this fifth, this can become a 5. So we have -24 times 1 plus 1 over 5 to the 19 all over 30. So we can take out a 6, so that's 5 and 4. So we have -4 times 1 plus 1 over 5 to the 19 over 5, or you could take out that 4 fifths. So you could get -4 fifths times 1 plus 1 over 5 to the 19. And that's good. That is reasonably simplified. Okay, let's look at this one. This is an infinite sum. So our infinite sum formula, how long? Wait, 10 minutes. Okay, S equals A over 1 minus R. So we need to know our A and our R. So this is confusing because it's not really in an R form, right? It's not in an A and an R form. So I'm going to put the first couple of, we need to see if it's geometric first of all, because it needs to be geometric to do this. So let's hope that it's geometric. But I'm going to write out the first couple of terms. So A to the 1, you plug in a 1. So you have 21 times 2 to the 3 over 3 to the 2. 21 times 8 over 9. So that's 3, that's 7 times 8. So 56 over 3 is our first term. Let's look at our second term. So you have 21 times 2 to the 4 over 3 to the 4. So that's 21 times 16 over 3 to the 4th, which is 81. Take out a 3, you have 27, 7. Okay, that's going to be a pretty big number, 7 times 16 over 27. So let's do one more, and let's not multiply that out. So it's something over 27, 7 times 16. Let's do one more, a to the 3 equals 21 times 2 to the 5th over 3 to the 6th. So again, these numbers are going to get really big, right? 21 times 32 over whatever 3 to the 6th is, 81 times 9. So that number is giant, right? But let's look at our common, we need a common ratio. What are we multiplying it by? So our first term is 56 over 3, right? We know that one. And then I'm multiplying it by the next term. I'm multiplying it by 2 on the top, right? Because it's 2 cubed on the top, and then 2 to the 4th on the top, and then 2 to the 5th on top. So I'm multiplying it by 2 on the top, and then I start with a 3 squared on the bottom, and then I go to the 3 to the 4th, and now I'm going to 3 to the 6th. So I'm actually multiplying it each time by 3 squared. So my a to the 1 equals 56 over 3. And then my r, on the top I'm multiplying it by 2 every time, and on the bottom I'm multiplying it by 3 squared every time, which is 9. So that's my r. So this one was kind of a tricky one to figure it out, but I would write out the first few terms and kind of see what you're doing each time. Sometimes they're going to be nice terms, sometimes they're not. But so now I can find the sum. Change colors. S equals, hopefully this isn't a terrible fraction because I don't have much more room. Maybe I can do that. Oh, look at that. 56 over 3 divided by 1 minus 2 ninths. So that's 56 over 3 divided by 7 ninths, which is 56 over 3 times 9 over 7. This isn't so bad. Times 8, right? Yeah, which is 24. So who knew that answer would come out so nice? All right, so I think that that's a pretty good kind of looking through the test. If there are other ones that you guys want me to work, just send me an email or send Mr. Blackburn an email, and we'll get those up. But that's a pretty good, I think, start to your review. All right, have a good weekend.